Today, I'm going to show you how to master N8N by focusing on just 20% of its features to get 80% of the results. I've personally built over 150 automations, generated a lot of value for my clients using literally only 13 core nodes. But most people waste months trying to learn everything when you can actually get results in just a few days if you focus on the right things. It's so easy to get stuck in tutorial hell, jumping between videos on YouTube. I've done the same, trying to master every single node and actually making zero real progress. But this approach is definitely costing you. And in this video, I'll show you exactly which N8N nodes and concepts matter most. So let's jump straight into it. So let's talk about the 13 nodes here, and we'll start with the execution essentials, as I've called it. So there's a few conventions when you're starting with N8N that you need to know and are really important when you start building out more complex workflows. The first is flow direction and order. So we have some sample nodes here to demonstrate this. If I have like a trigger here, and we'll talk about triggers in a second, and it's connected to multiple flows. Firstly, if it's connected to just one flow and we run that, everything runs from left to right. So you can see how it's run starting with this manual trigger and running left to right. The second thing here is actually if we connect it to multiple flows, where we have flows at the top and flows at the bottom, everything at the top of the flow will always run first. We can demonstrate this by running the top flow, which you can see is run here, and the second flow is still running at the bottom here, where we've just got some example data and a wait node. However, if I drag this up to the top here, you'll see that actually this executes first because it's at the top of the flow, and then it jumps down to the second flow, which executes last. You can probably see when those two run at the same time, actually they're not running at the same time, and this is called sequential execution. So by default, N8N executes nodes synchronously, i.e. one after the other, not in parallel. So when we run this, it will run the top flow first, and every node executes individually, synchronously, one after the other, and then it will continue to execute those. If we have these connected up to the same node here, you'll see exactly the same behavior where it will run the top flow first to its completion and then run the bottom here. The next thing you need to know that nodes will run once per input. So if you have 5 inputs, it will run 5 times. And you can see this demonstrated here where we have some example data, which is just some lead data, which we'll continue to use throughout this demonstration. And you can see we've got this nested data of different leads. So if we look at the schema output here, we can see that this is a leads array and it contains information of multiple leads. So this is Sarah Johnson, then we've got Michael Chen, and each of those lead components are contained inside this JSON array here. If we decide to split that out into individual components, we can see that now we've got a structure that's more familiar with a database table where we have each person or each lead in a separate row. And once we split that out, it's no longer in one combined array, i.e. one item, it's now in 5 items. And then when we hit this condition here, which is if a condition is true, you can see that 5 items are passed into this if node. And we can actually see in the run here, or the first run where it received the top branch, actually it processed 5 times this condition. So for each input, it processed it once. The second thing you'll be able to note here is branching. So you can actually split workflows into multiple paths using conditions. So say, for example, this data was being passed through in the top here. We might have a condition that says, if before this date, take this action. If not before this date, then take a different route. So we're able to actually branch and take different conditions, almost like if this, then that actions, some deterministic actions based on the data itself. And then the final thing that's really important around conventions is that your workflows will start as inactive up here. But actually, if you want it to be activated by external data, then we need to come up here and we need to click this toggle to activate the flow. But we can only do that when we've got a trigger that needs to be activated externally, like a webhook trigger, a time-based trigger, etc. And without activating it, none of this will continue to run unless we are manually running it in our test workflow node here. So with that being said, which then are the most important nodes that you need to know to get the most out of N8N. We'll start with some of the basic triggers. Now, you've already seen this manual trigger. This manual trigger you'll continue to use again and again. It's very straightforward. It's basically when you click this test workflow button, the manual trigger will run. That is as simple as that. They've also got this test workflow button that's connected to the manual trigger itself. You will use this continually throughout testing. We then have a cron trigger, or a schedule trigger as it's called in N8N. And what we're able to do inside the schedule trigger is define at what interval this is going to happen. So for example, we could say every one day at 5 a.m., we are going to run this workflow. And to make that happen, we then need to activate the workflow like this. You can see we can now activate it because this has been turned on. So this is useful for things where you want to run something at a specific time. Maybe you have a daily report, a weekly check, something like that. You will always use things like schedule triggers. And you can even get as complex as doing a cron job, which is defining exactly which day, month, hour, second that something is going to run, but mostly you're just going to use the inbuilt seconds, minutes, etc. to run those. The next trigger that we've got are app events. So we use N8N a lot to connect to our external apps like Airtable, Google Drive, OneDrive, Dropbox, Outlook. And actually, this is why workflow automation is so powerful, because we can connect to all of our business software. So we've got an example of the OneDrive trigger here. And inside the triggers, we've got this on app event. So this runs the flow when something happens in an app. And here we use an example of OneDrive. So say something is updated in our OneDrive, we can basically ask OneDrive every minute or poll it, or every hour, every day, the same as the time-based trigger here. But we're saying check a condition every X minutes. And we're saying the condition here is going to be a new file is created or a new file is updated. Or in your Google Sheet, this might be a new row is added or data is changed. So pretty much any condition you can think of can be activated specifically through a specific app. So let's say Google Sheets. We click on the Google Sheets node here. We've got 3 triggers: on row added, on row updated, or on row added or updated. We can trigger an action, which would be, in this case, our workflow. So those are the core triggers that you'll end up using in N8N and need to understand. We will then look at universal data processing. So you will start a flow with some sort of activation trigger. It always needs to be started with a trigger, i.e., why should this workflow actually start? This universal data processing is all about what should you do with the data that you receive in order to transform it. So we've got our leads data again here with Sarah and Michael, and there's a few key ones you'll see again and again in your workflows, and I use continuously. And once you understand these, you'll understand the 80% of what's important in data transformation and how to use those. So we've got this leads database, and let's just run this through here. We can see that inside our schema, which is a view of the data that's nested. So we've got this leads here. So that's that leads array here. And inside that, we've got individual items, or it's nested in an object effectively. So each lead is split into this lead and then the index or the number. So for example, we've got Sarah Johnson, which starts at 0 because all of our indexes start at 0, or you can see it in a table, but you can see it's one object still. Now, when we're coming to process that data, we often want to flatten the data structure in order to be able to turn this into a data set where it's split into rows, for example. So right now it's one giant object that has a nested structure, and you can see that in here. It's a nested structure. But if we wanted to flatten that data structure, as it's called, we would use this split out node. And you can see if we run that, exactly what happens. So we've gone from one giant data array in here to individual rows where we split out that. And we can decide based on the inputs for how we're going to split that out. And we can decide also which fields we want to split out there. You might have the inverse problem where actually you have all of these rows of data, but in some cases you want to group that all together. Say you're passing that data set through into an AI node or an LLM chain where you don't want to pass 5 items in. So we spoke about earlier how each item is processed once by a node. If you actually just want to pass in the data set as a whole, so the whole leads data set, then you might have this data to start with in rows, and you want to aggregate that data. So it's more like the input we had to start with, which is actually grouped together, and you can process it in one go rather than running a node 5 times. So in this case, we'd use the aggregate node, which actually pulls together again the leads back into this nested structure. And you can see we've got exactly the same as we had before because we've aggregated all of our data into a single list and decided to include all of our fields there. If we wanted just the name, then we might say, let's just do first name here. We'd have to name it exactly how the input data is. And it's just going to give us an aggregated data set of those names. And we can effectively put anything here. We could put second name as well. And we'd run that through. And sorry, it should have been last name. And you can see now it's aggregated just those values. So that is 80% of data manipulation in terms of flattening and merging that data set together. And you will continue to use those a lot. We then have the set node, or edit fields node, as it's now called, which is a way to effectively create and modify data fields. And you will find yourself using this a lot when you have a large set of structured data coming in. You might only want to call out specific fields that you want to process and move on. So you're not processing too much data. And for this, we'd use the set node. So if I pass in the data from the split out data here, what you might want to do, for example, is manipulate the data in some way. So say, for example, that we want to make full name from this first name and last name because we want to send these leads an email with their full name. Then what we would do is we would just create a new field in this set node. We'd call it full name. And we would effectively turn this into an expression which says I can now receive dynamic values from the data that I'm receiving. And I would literally just drag and drop the first name and I put a space between them and the last name here. So you can do as much data manipulation as you want with JavaScript expressions here. But the point is we can actually manipulate data or only pass through the data that we want with these set nodes. So say I wanted to pass through the full name as we've got up here and all other data fields as well. If we process that, you can see we've now got everything, but also the full name column at the end. So we've added to our data there. But say I just wanted the full name and I wanted to get rid of all data. If we had thousands of rows, then we might want to strip out the data to just the bits we need. Then I might say, okay, actually, I just want the full name and I'm not going to include any other input fields. And I'm just going to pull the full name here. And we can add as many fields as we want. We can also drag and drop them over here and they will automatically populate with the fields that we want. So say we wanted full name and email only, we could do this with the set node. And it's a really powerful way to strip out the data and kind of clean it or manipulate it to exactly how you want. We've then got the if node. So you will see so commonly, we've got to make a decision where we branch in two directions. So if this condition is true, take this route. If this condition is not true, take the other route. So we would just have a condition connected here where if the full name, that shouldn't be an expression, is equal to Sarah Johnson, let's specify Sarah Johnson here, then it's going to be true by default. Everything that is not Sarah Johnson is going to be false by default. And you see that's come up with all false there. And that's because I've not actually pulled in dynamically the full name column here. So this is now comparing the full name column to Sarah Johnson. And you can see that that is now true for one branch and false for the other. So any items that are in the true branch can take one condition up here, and any in the false branch can take a different condition and do different actions off the back of that. So that's really powerful. Another way to do that is the switch node. We're not going to cover that today, but that's if you have more than two conditions and you'd use a switch node to say, if this condition is true, or if this condition is equal to this, then take one of these 4 to 10 routes instead. But the point here is conditional branching. You can take different actions based on the route here. Now, the code node is the last one in the data processing that you might have to use. And this is when you need custom manipulation of the data for more complex transformations that are not available inside the N8N nodes. And you can often use something like Claude or GPT to help you craft these. And I'm going to show you very quickly how you can just craft this code node very easily. So let's say that actually we're going to put a comma, just for argument's sake, between the first name and the last names here. We're going to pass through all of the data. So now we've got the whole data set, but we've got Sarah, Johnson. And what we're going to do is get rid of the if node. And we're going to say all of the data that's going into this code node, we want to take the full name and we want to strip out the comma. So this is something that would be harder to do with traditional nodes because it's more complex. We're pinpointing an exact character that we want to split by. But once we open this code node, we can say we want to run it once for all items that come in. We want to choose the language. I commonly use JavaScript because that's what I'm familiar with. And then it'll populate with an example that says loop over the input items and add a new field to the JSON of each one. So the example basically loops over all the items, and we can see it here, and adds a new field called my new field 1. Now, if we wanted to, for example, strip out the comma, then we're going to need to find the JavaScript to understand where the comma is in the field. We're going to need to point it to the right field, and we're going to effectively have to strip out that comma and call that a new full name field. So for simple use cases like this, I would go to Claude, I would copy in this code example, and I would say using this format, and I would copy an example of the JSON data. And I'd say in N8N code node, help me create a node to strip out comma characters between a first name and surname and populate into a new field called full name new. And then I would copy the data set in. So I've basically said, this is what I want to do. I've copied the data set in and using this format from N8N code node. And then I've copied in their example. And what that's going to do is spit out a draft code node that I can go very easily put into here. And we can test that. So I'm going to copy that directly into the code node. And this is how I would build all code nodes. And you can see it's put some comments in here. So it's looking for the comma, it's going to remove the comma and any extra spaces. It understands because we passed in the data that we're basically going to grab the full name field here. So it says item.json full name. And when you distill this, it might be quite complex if you're not used to JavaScript. You can start to read through and understand each of these because it went for us. And let's give that a go. And it's done exactly as we said. So full name new column, Sarah Johnson, Michael Chen, Jessica Williams. So we've used that for some more complex data manipulation. And you don't need to write these from scratch. You can start basically troubleshooting with something like Claude and actually get 90% of the way there. So that is the code node there. And I will put those all back. Once you understand those concepts for universal data processing, that is actually the time where you will spend most of your time when you're building out complex automations, either for your business, yourself, or your clients. And is often seen as the hardest parts. But once you understand those nodes in its entirety, that is actually honestly 80% of it. Now we'll talk a little bit about connectivity and APIs. So when there is not an inbuilt node for a specific app, so say, for example, we've got Google Drive in here, that is a specific inbuilt node for a specific app. But when we do not have that, we need to connect to an API or connect to a web page, and we use a HTTP request to do so. So this just allows us to connect to any external source through one single node. So we use HTTP requests a lot to connect to different API endpoints. If It's not one of the 1,000 plus nodes that are already inbuilt to N8N. There are two most commonly used request types or methods for HTTP requests. The first is GET, and as it sounds, that retrieves data. And then we have POST, and as that sounds, we send data or we post data to a service. So I've got an example here that will make this very straightforward, and then we'll talk about how you authenticate it. We've got dummyjson.com/products, and if I go to this web page here, you will see that this is literally a site designed so that you can make fake HTTP requests or API requests and retrieve dummy product data to populate your service. So this is going to give us basically a product endpoint, which is just a URL we're grabbing from, a bunch of product information if we request information from it. So we've got down here, get all products, and it tells us we need to fetch from this URL here, which is our endpoint that we're grabbing it from. We go back to N8N. All we're going to do is copy that into the URL column, get rid of the quotations around there. And because there's no authentication required, i.e. we don't need to prove that we are who we are, then we can just actually run that. And what that's going to run is it's going to give us a bunch of product information. So you can see Essence Mascara, a bunch of information around the actual product, some reviews. And this is all fake product information that we're just pulling from this service. And you can see it's in one massive nested object like we had before. So if you were going to use this product information, you might want to use the split out node like we had before. And then you can see it's got all of this information. So actually a lot of information pulled really, really quickly from there. So that is how to grab data. And you'd use this if you wanted to grab data from an external source that is not available inside N8N. You just need to figure out the endpoint, and that would commonly be in the API documentation. Now, if we wanted to post data or send data, we could find one here that says, okay, if we wanted to add a new product, then we're going to need to send it to this URL endpoint. So we've got this dummyjson.com/products/add, and I'll just duplicate this so that we've got it in the examples. So this is going to be our post request because we're sending data, and we're going to post in that new URL. So this is if we are sending data to an external database or API system or system. When we're connecting between systems, we are actually sending data to update it in a different place. So if, for example, here we're going to add data, then it tells us we need to use the post method. So it'll always tell us which method we need to use anyway. It tells us we need some headers. So when we send a request, we have these things called headers, which basically just tell the receiving system or computer what kind of information it's going to receive and where it's coming from. So the authentication here, which we'll touch on in a minute, it will tell it in the headers what kind of authentication key is coming. But in here, for example, we've got the content type as a header. So we remove these quotation marks, and we're just saying that we are sending data in this format, application/JSON. So we are sending JSON data, which is our structured object data that you saw before. We're sending that. By default, N8N actually sends it as JSON data, so you wouldn't need to put in this header type, but I've shown you so that you can see other header types. And then that is it for the headers. You can see the headers section there. Inside the body, we're actually going to send the product data itself. So you can see here BMW pencil, and it's just said, turn this into a string or a set of sentences or characters. You don't need to worry about that. So we'd actually send the body here if we're sending data. And N8N makes this really simple because actually all we're going to do is say, okay, the title, which we know is an attribute of this product, we'll say BMW pencil. And actually, let's give that a go. And what that response has told us, so we get a response from the system, is actually we've added that to the system and we've given it ID 195 with this product attribute. And we could add as much as we wanted. And I'm sure we could add some other data as well. Maybe they have price. Let's see if we get a rejection there we go. It's because it's an open system, it allows us to effectively put in any attributes and it will always receive a positive response. You will sometimes get back here a negative response, which often means you've sent the wrong data or you've mapped it to the wrong field. So say price didn't exist on the other side and I was trying to send it as price, then it would get cancelled and tell me I need to try again and rename the field and the errors would come up there. The final thing about HTTP requests are authentication. So if we were sending to a service where we would conventionally have to log in, we'd often have to use API keys or authorizations like passwords, and we might use these generic credential types. And credentials are just our way of proving that we are who we say we are in order to add data. So the most often one you'll use for this is a header authorization. Like I said, this gets put into the headers automatically. So we don't need to add it here in the headers column. We would create a new credential. And inside the service API documentation themselves, it would usually say something like, we need to enter in the name authorization. And 90% of the time it's authorization like this. And then inside the value, most commonly, we'd put bearer, the word bearer, space, and then we would paste in your API key, which you'd be able to grab from the service. this would appear as obstructed like this, obfuscated rather, so we wouldn't be able to see it. But what that means if we're saving it in there is that actually in future we can access that through header auth account 3. And you can see I've got a few examples in there. And there's lots of different examples that I've used in the past here. But if you go into any of them, you'll be able to see that this was the header name. If I go into Firecrawl, you've got authorization and then bearer dash the key. But it means that everything is obfuscated when we send it because it's saved as a secure credential here. But in this case, we didn't need to prove who we say we were because this is a demonstration website. Now, on the other side of connectivity and APIs is when we actually receive ourselves data from an external service. So if we're not requesting it, i.e. we're not sending a HTTP request, we can actually get other services to send it to us and we receive it via a webhook. So you can think of this as a HTTP request in reverse. We receive that data that's sent to us. So for example, we'd have a webhook trigger here, which if we go into that has an address, a webhook URL, exactly the inverse. This is the URL that it's going to send data to us. So we can see this is a GET request. And what we do is we just click to copy this webhook URL. So if we're running this in test, we would literally click this here in test, and we can go to a service like Postman, which is basically for testing different API endpoints, etc. We can try and send a new request, and we'll send a new request to ourselves. I go to test webhook. In here, I'm able to send a mock request, and I'll post in the address that I want to receive that request to. And we will just say, okay, inside the body, let's add some form data. Let's call it test, and let's say hello. And we can add binary files, we can add PDFs, anything like that, any form data we want. And what we're going to do is we're going to come out here, and we're going to say listen for test event. And what we're going to do is send that request. Okay, so we tried to send data for post requests here. We tried to send something in the body, but this is actually a get method. So this is a good example of where we'll stop listening here. We'll turn this to a post request because we're receiving data. And actually, let's just make sure that we're sending it to the right address. And let's activate that test event again. And we should receive that test hello here. So it's saying actually it's sent the data, and you can see we've received information from the headers. So like we said, it's basically told us information about the system that's sending it, including the content type. And then we've received in the body here, the hello that we sent. So basically you can send predefined sets of data from external services to a webhook and receive that data and use that often to actually activate a workflow. So a good example of this is maybe somebody purchases your product through Stripe. You are getting Stripe to send you information via webhook. So you don't need to request every minute from Stripe. So they will send information to your webhook, and that will then activate your workflow. Then the response to webhook node is effectively what information do you want to send back and when do you want to send it? So when we have this response to webhook node, which we need to use when we have a webhook trigger, we could have this at the end of the flow, which says actually just respond with all incoming items. We could say respond with the first incoming item. We're basically telling the service that we've received their response successfully and we've communicated that back to them. Once you get your head around all these HTTP requests and webhooks, you're honestly 90% of the way there. We've then only got two other core sections to discuss, starting with storage solutions. So after you've manipulated your data, you've grabbed data from external data sources or received it from external data sources using a HTTP request or webhook, you've manipulated it using these universal data processing, then one thing we're going to need to do is actually use some sort of storage where we're actually sending our data to. So if we're not sending it to an external surface, you'll often be connecting to maybe a Google Sheet or an Airtable or a database that you use or Notion or any of those storage solutions. So the most commonly used ones are Airtable and Google Sheets, but the same concepts apply here for multiple. So if, for example, we were going to grab data, let me just bring that node down here. We would effectively have this leads data again, which we'll use as we're familiar with that. And we'd need to process the data and then add it into a Google Sheet. So if we're doing it for something like Google Sheets, then we need to make sure that we create the sheet first. So we'd open up the Google Sheet node and we have an option here, document action, to create that spreadsheet. And that is just this here that I've renamed. And we're creating a document and we can give it a random name here. And what we're then going to do is append the data into a Google Sheet. So we're going to say, okay, based on that Google Sheet ID, let's append that data. So for example, let's run this now. And this is an important error here to take note of. If you're testing multiple nodes like this and you've not set up the others correctly, then you just need to go here and actually deactivate that node or hit D on your keyboard. It will deactivate those nodes which are causing errors. Any of these, let's just deactivate so that we can make sure we can run through this. So if we hit test workflow, it's going to run through. It's now created a Google Sheet for us. So it's given us a spreadsheet ID and the properties of the spreadsheet. We have our leads data there, which we've then split out into our individual rows as we saw before. Now what we want to do is actually store that data somewhere. So what we're going to say is, okay, we're going to grab the document that we created before, which you can see in this schema view here is actually in here, this create sheet document. We are going to put in the spreadsheet ID here. And that says, okay, grab the spreadsheet that we've created before and add this data. And what we're going to do is we're going to append the rows of data from the last node, which you can see are our individual leads here. You can see that in the data here, our individual leads from the last node. And what it's going to do is just put it into the specified sheet. Now, if we've already created a sheet, we don't need to do the create sheet stage. We can actually just link it up to a specific URL or from our list. But because we're creating a sheet as we go here, we're going to say, okay, put that information to sheet one. And instead of mapping the columns manually, because there's currently a blank sheet that we've created, it's got no columns, what we're going to do is just tell it to map the columns automatically. But if there's a blank sheet already, and we don't have these names in here, like ID, first name, email, company, etc., then it's not going to add any data to the sheet because it's not going to be finding the column headers. So what we need to do is tick this option, handling extra fields in input, and we're going to say, okay, for every new column, when they don't match a current field, insert it as a new column and add that data. So let's run that, and we will open up the Google Sheet, which you can do directly from in here. So we've got the items split out. Let's open up the Google Sheet, and you can see it's automatically added those new columns for the fields that it didn't have before, and it's added the data to a sheet in a more familiar format that we're comfortable with. So once you've manipulated the data using these steps up here, you can actually then put that into a usable format for yourself. The exact same applies for Airtable. It's just Airtable is more of a database than a sheet. So we choose which base we want to access, etc., and add that to a database or storage solution that we can use. You so commonly in N8N will need to add this to a usable format like Google Sheets, etc. Same applies for any other database. Similar concepts, just different operations in here. We can also do things like manipulate the data, receive the data, only change the data when an update is needed rather than refresh and append new data every single time. But we're not going to cover that here because you just need to know that you can add it to a database and grab information from that database. And equally, you have on the other side the Google Sheets trigger, which will effectively be if a new row is added, then we can use that as a trigger to start a new workflow here. And let's just deactivate those here. And then we will look at the last of the 80/20, which is, of course, AI integration. So we have two core sets of nodes in N8N. They're going to be most important for you if you're actually leveraging AI. So the LLM node, or the basic LLM chain as it's called, you can access through here, through AI, and we go into the basic LLM chain, is exactly the same as if you were talking to ChatGPT, although we enter our message inside this source for prompt, we define it below, and we put it into this user message field here. Now, when would you use an AI node versus just using the if this, then that logic? Basically, when judgment is required. So if your flow is going through and if this condition is true, do this. If this condition is not true, do this instead. If that traditional deterministic logic is not going to be good enough, i.e. you need some judgment in there, that is when you would advance your workflows using AI, and not until that point is true. You don't just use AI to process things that you can process through normal workflows. So traditional nodes work perfectly for examples like if this invoice is greater than $1,000, send to approval. You don't need AI to do that. But it falls short that when you need that sense of judgment or human judgment in there, because they fall short if you have an example like if the customer email suggests they might cancel, then flag for retention. So it's going to read the language in a customer email and flag for retention. Now we could say, if they say this specific word, then flag it for retention. And that would be deterministic. But if we are saying actually understand the sentiment of the incoming message, whether it's positive or negative, and therefore flag it in an appropriate way, then that is how we're going to use this. So as an example here, we're going to use the sentiment. And what we've got is an incoming input, which is a customer message. And here we said the customer service is awful. And inside the basic LLM chain, like I said, we define the prompt below and we put it into this user message here. And if I just deactivate this and connect the chains, let's run this input so that we can see exactly what's being input here. So we've turned this into an expression again, because we want to take the customer input from here. And all I've done is a very, very simple prompt here. Determine if the incoming message is positive or negative and return a summary of sentiment and reasoning. So we're asking it to make a judgment. And then we've actually grabbed, and you can do this by grabbing this again over here and pull it in here. And that just puts the input inside here. So now you can see if you open this up, this is actually what the LLM chain is going to receive. Turn a sentiment and reasoning, and then we should probably say something like the input is the customer service is awful. And that's going to process. There's a couple of things else you need to know to use the basic LLM chain. The first is the model that you're connecting to. So I tend to use OpenRouter, which allows me to connect to any of the different models and change them really easily through one credential. So for here, we're going to use GPT-4o Mini, which is an OpenAI model, but you can also use things like Claude, Anthropic, Gemini, any model you want to use here. And the second is our structured output parser. So if we require a specific output format, we can tick this box and it will have this additional output parser here. And we can say, okay, let's give an example of what output we expect. And therefore it will give us in that output. So here where we're saying return a summary of sentiment and reasoning, we might say sentiment and reasoning. And we might say as an example, positive. And we might say the customer seems enthused about the service as the reasoning. And we're basically suggesting that the LLM should return its outputs in a similar format to this. And I'm not sure I spelled sentiment right there, but it doesn't matter for the example. So let's test the workflow. And it runs through that structured output parser. And now you can see in the output, it's actually given us a JSON output, an object of sentiment, negative, reasoning. The phrase customer service is awful indicates dissatisfaction with the service provided, clearly reflecting a negative sentiment. So what we've done is taken a non-deterministic flow here and made it more deterministic by actually getting the LLM to make the judgment for us. So that is where you want to advance your workflows here. There's also an advancement on this output parser, which is an auto-fixing output parser. So if you have more complex outputs, what you do is you connect up your model here, you tell it this is the output parser I want, and then the auto fixing is just going to say keep running until you get this damn output. Don't stop if you haven't got this output format, and it will continue to run. So it might run several times, but it'll save you from it erroring out every so often. But we don't need it in a simple case like this where the judgment is very limited. Now, the only other thing you would use here is an AI agent. So AI agents are so overused when they don't actually need to be used. You can often use a basic LLM chain for 90% of the AI work, and then even before that, you can use workflows for so much more. But an AI agent you would use in the case where you need to have an ongoing conversation with memory, for example. So record chat memory. You'd use it in the case where you actually needed to access certain tools. So say this was not about sentiment, or say it was about sentiment and we actually wanted to draft an email off the back of that back to the customer, or a message back to the customer in our inbox, and we would connect it to something like our Gmail tool, and we would tell it in the prompt to draft the message inside our Gmail tool, and we would put this tool as to send a message or draft a message or whatever we wanted to do, label it as something, and we would then basically in the prompts tell it to actually use that tool that it has connected to take those certain actions. So you only need to use an AI agent here when something more is required. It needs to do some thorough thinking and interact with itself. It needs data access, it needs tool access, it needs to access its external service. Before that, you're just going to use the basic LLM chain, and that's going to get you 90% of the way. So all of those concepts are going to round up the 20% of nodes. They're going to take you 80% of the way to creating excellent workflows and also empowering them with AI integration. If you like the video, please give it a like down below. It really helps me reach a wider audience. Thanks so much for watching.